Assalamu alaikum. In this lab activity, lab demonstration, we are going to apply a stack array which we had developed in the previous lab to convert an infix expression to a postfix expression. We have seen in the pre-lab video that the infix expression has its limitations of operator precedence, which the postfix notation does not has. So it's a more straightforward way of evaluating an expression for the compiler. Let's begin the pre-lab session. The pre-lab section gives a brief algorithm for converting an infix expression to a postfix expression. This is the example. For example, an infix expression is the one in which the operator is mentioned between two operands, and it translates to an equivalent expression in which the operator appears after the operands. Okay, and the postfix expression, as we had seen in the class and in the pre-lab video, that the postfix expression does not have the problem of operator precedence, and it's pretty straightforward to be evaluated. So this is a brief revision of the operator precedence that in this for this lab, for this program, we are assuming that the operands are digits and characters 0 to 9 or A to Z. For example, if you have the expressions in this format and not in the actual values of the operands. Also, the valid operators are plus, minus, addition, subtraction, multiplication, division, and parenthesis. So among these operators, we know that the highest precedence is of multiplication and division, and they both have the same precedence. Lowest precedence is of plus and minus, and they both also have the same precedence. Okay, the opening parenthesis has lowest precedence on the stack and highest precedence outside of the stack. We explained it in the pre-lab video. What does it mean to have precedence of operator on the stack and precedence of the operator in the input string? Okay, this closing bracket, it never goes onto the stack, and this opening, it just is used whenever it appears in the input string. It is used to pop all the operators from the stack until an opening bracket is encountered on the stack. One thing to note is that both these opening and closing brackets, they don't come as an output with the output string or with the postfix notation. Okay, bottom of stack has the lowest precedence than any other operator, which means that whenever the stack is empty, any operator that appears in the input string, it just gets pushed to the stack. Okay, so the general algorithm is, while there is more input, for example, which means that while there are some characters in the infix expression, if the input is an operand, for example 0 to 9 character or A to Z characters, then you just print that input, which means that you just output it to the postfix notation. Else, if input is an opening bracket which has lowest precedence in stack, highest outside, so still the stack is yet empty. So if you come across an opening bracket in the infix notation, infix expression, you just push it onto the stack. Else, if input is a closing bracket, then what you do is you check the top of the stack. If it's not an opening bracket and the stack is not empty, then whatever operator is on the top of the stack, you just output it to the postfix expression. Of course, it should not be just an opening bracket on the top of the stack, because when an opening bracket is on the top, when an opening bracket is encountered in the infix notation, we push it onto the stack. Okay, and if an closing braces is encountered in the input string, the infix notation string, and the top of the stack is a closing bracket, it means that there was nothing in between these two opening and closing brackets. So it doesn't make any sense to have the brackets while there is nothing inside. So whenever closing bracket is encountered in the input string, we print whatever operator is on the top of the stack, and we pop that operator from the stack. Okay, like we remove it from the top of the stack, and we do this until we encounter this, and we or the stack is empty. So if the stack is not empty, pop stack. Okay, and else error. If the stack is not empty and you don't encounter if the stack is empty and you don't encounter an opening bracket, then this is an error, because there is no matching opening bracket for a closing bracket encountered in the infix notation. Else, if input is any of the valid operator, you have to check the precedence of the operator. What you do is, if the stack is empty or the precedence of the operator at the top of the stack is less than the precedence of the operator encountered in the input string, which is the infix notation string. So if the precedence of the stack operator, the operator residing on the top of the stack, if it's less than the precedence of the input operator, then you push the input operator on the stack. For example, if plus or minus operator is on the top of the stack, and in the input string you encounter multiplication or division, then you just push that onto the stack. Else, if precedence of the operator residing on the top of the stack is greater than the precedence of the operator in the input string, for example, there is a multiplication or division operator on the top of the stack, and you encounter plus or minus in the input string, then what you do is, while stack is not empty and precedence of top of stack is greater than or equal to the precedence of input, you print top of stack, and you pop the stack, which means that the operator on the top of the stack is popped and it is attached to the output string. And then when either the stack is empty or there is an operator which has lower precedence than the one in the input string, then you stop and you push the input you push the operator which you encounter in the infix notation, which is the input operator, you push it on the stack. Else it's an error. Okay, because if the operator is not a plus, is not a multiplication, division, addition or subtraction, then it's an invalid input. So after that, what you do is, while this all is evaluated, this algorithm runs when there is input, for example, while there is more input. So while stack is not, for example, if the input string ended and there are still operators on the stack, then while stack is not empty, print top of the stack and pop stack. You pop one by one every operator from the top of the stack, and you keep attaching it to the output string. Okay, so this is a detailed algorithm. These are the steps written in verbal form. And so now we will move towards the implementation of these steps And after that, once we are done with the lab demonstration, the actual lab activity that you are supposed to perform is that you have to write a program that uses a stack data structure to evaluate a postfix expression. This is pretty straightforward. There are no precedences to be checked. There are no ambiguities or confusions. It's a pretty straightforward task. You need to have a stack which will store the operands. So whenever an operand is define a stack that holds operand, read the input string one character at a time. Note that the input string in this case will be a postfix notation string. So ignore blank spaces and assume single digit numbers only, for example 0 to 9. For every operand, push it onto the stack. For every operator, pop two operands from the stack such that first pop gives the right hand side of the equation. For example, when you first pop, let's suppose that there is a stack, and that stack has this appearance. There is one operand, and then there is another operand. Let's suppose first we have 6, and then we have let's say 9. Okay, so let's suppose that in our postfix expression we have 6, 9 minus whatever 3 plus etc. Okay, so the 6 comes, you push it onto the stack. 9 comes, you push it onto the stack. Then there is minus. So minus is an operator. What you do is you pop two operands from the stack. So 9 is popped, and the first pop will give you the right hand side, for example 9, and then the operator which is minus, and then the second pop will give you left hand side. So so this, and then you perform this 6 minus 9, and then perform the operation on the operands according to the operator and push back the result onto the stack. So after performing this 6 and minus 9, the result will be minus 3. So what you will do, you will you pop this 9 and 6, and you will push the result which is minus 3 onto the stack, for example like this. Okay, process the entire postfix string, and the resultant value on the stack should be the final result. Okay, so once the entire string has been processed, the final result on the stack will be the result of the of evaluating the expression. Okay, so let's move to toward the implementation of our infix to postfix conversion. So I call it into post class. Okay, so what we need in to perform all this process is a string which is an input string, and a string which will be the output string, which will be the postfix notation. Okay, then what we need is stack basically. So I assume that you already know about the important operations of the stack, and I have this stack defined here as a separate class. So this stack has all the nuances of the stack data structure. For example, the maximum size, the actual array. In this case we are dealing with characters, so I have this stack array as a character array, and then a variable to indicate the top index of the stack, and this is the constructor in which I am initializing the maximum size, which I will pass when I will instantiate this stack, or will make the object for those who are not using Java for the implementation, or who are not using object-oriented concept. So in the last lab we performed everything in the main function, so we will do all these three steps in the main function of the stack. Okay, and then I created this stack array, and I initialize the top to -1 to indicate and identify an empty stack. Then there is push, then there is pop, and peek and is empty, which just checks if the stack is empty. Okay, so I need an object, or I need an instantiation of this, an instance of this stack. So I call it this instance of stack as the stack. Okay, and then what I do is in a constructor to this class input to post, what I do is I pass the input string, and I initialize the input string of this class variable to the input string that I pass here. And then I also initialize the now this for this input string I would need a stack of certain size, which I determine from the size of this input string. Let's suppose I calculate first the size of the stack. I call it stack size, and I determine this size by the length of this input string. Okay, and then I initialize my stack. The stack is equal to new stack of size, stack size. Okay, so this will instantiate my my stack. Okay, next thing what I do is I define a function which will return me the postfix notation string, and let's suppose I name it do the transformation, or do trans, or do translation, or do conversion, whatever name you put to this function. I pass it my infix notation string. Okay, and it will or maybe I don't pass it my input string, because the input string is the class data class variable, and this function has access to that, so I don't need to pass it. Okay, so what this function will do. Okay, now I have my infix expression as a string, so I have to read it character by character. So for that I use a for loop. I'm keeping this implementation as simple as possible. There are many versions of this infix to postfix conversion, ranging from the simplest one to the most sophisticated and complex programs for that, but we will try to keep it simple. So this loop will run from the first character of the infix string to the up till the last character. Okay, and for every character read in this string, what I do is I read that character ch, let's suppose, is equal to input string dot character at index j. Okay, then what I do is I use a switch case on the basis of this character. Okay, and I can have various cases. For example, there can be a case when this character is a this character is plus addition, or there can be a case where this is subtraction, or there can be case where this is a multiplication, or it can be a division, okay, and it can be opening or this bracket, it can be a closing bracket, it can be a closing bracket, and then there can be, yeah, or there can be a default case as well. Okay, so let's break all these cases. Okay, plus and minus, they have the same precedence, so I define only one case. I define only one case for this. So if the case is if the case is an addition operation or a subtraction operation, okay, what I do is I define a function named as let's suppose got operator, okay, and then I define another function. You will just understand why we need these functions, got operator and got parenthesis, okay. So okay, what this function, let's suppose if the case is that the character I read from the infix notation is an addition or a subtraction, I call this method that I got an operator, and I got this operator and I pass it the character, and I pass it a precedence. Let's suppose this has the lowest precedence among all the operations, addition and subtraction have the lowest precedence, so I pass it a variable precedence 1, and I define this precedence 1 to be a variable which has the value or maybe we don't pass it as a variable, we pass it as a constant value. Let's say we pass it to 1, okay. Now here I define it that this method will receive two kind of parameters. One, it will receive a character, and other, it will receive a precedence, okay. We'll get back to what this operation has to do, this function has to do, okay. Then if there is and then we break this case, okay, then there is these two, and they also have the same precedence, and so we define just once, so, and we call the got operator method function, and we pass it the character, and we pass it a precedence which is higher than the precedence for we set for this plus and minus. So it was 1 and here it is 2. Now when there is an opening bracket, all we need to do is that when there is a opening bracket, we need to push this. So we have the stack has a method push, okay, and we pass this we push this character, which in this case will be an opening bracket, and we break this case. Then when there is a closing bracket, so we call the function got parenthesis, because if you recall, when there is a closing bracket, we need to pop all the operators on the stack until an opening bracket is found or encountered on the stack. So when there is this we got parenthesis method, we pass it this character, which in this case will be character. So here also we define it that it receives a character. Okay, and then we break this case. Okay, and then there is a default case. Sorry, there is a default case which of course is method. Which of course is it's not plus, it's not minus, it's not multiplication, it's not division, it's not opening bracket, it's not closing bracket. So it must be a an operand, and what we do with operand is we just attach them uh, to our output string. Okay, so what we name the output here. Okay, here output. All right, so output is equal to output plus character. So we attach it to the output string, and this is our switch case. Now in this got operator. Okay, all right. Return statement. Okay, this to transmission it doesn't return any. All right. So what this got operator method does is it we passed it the character that is encountered in on the infix notation. Okay, and it has to uh, check on the stack. So we need to see that if the stack is not empty, while not the stack dot is empty. Okay, what it does is it pops the character, let's suppose ch, and I sorry, please bear with me, there is some okay. So just to avoid confusion, I call it operator this, like operate the operator which we encounter in our infix string. Okay, and then I while the stack is not empty, I read the operator on the top of the stack and I name it operator top. Character operator top is equal to the stack dot pop. Okay, now this I have two operator. One I encountered in the infix string which I have passed to this method or function, and I call it operator this, and another operator top which is on the top of the of the stack. Okay, so what I do is that if this stack if this operator on the top of the stack, if it is if this operator top the operator on residing on the top of the stack, if it is closing parenthesis, if it's an opening parenthesis, this. Okay, then what I am supposed to do is that I don't have to do anything, and I just the stack dot push operator this. I have to push this this operator, whatever it is, I have to push it on the top of the stack. Okay. Else, and also I have to break this loop, because I am done with the operator which I encountered which I encountered on in my infix expression. Okay. Else, what I do is I introduce another precedence, integer precedence 2. Okay. And I have to value this precedence 2, and I will give it, or I will assign it a value depending upon the operator that I encounter on the top of the stack. So if this operator top is equal to plus, or it is a minus, then what I do is I assign this precision 2 is equal to 1, because if you recall, when plus or minus is encountered in the infix expression, we passed it precedence 1. So precedence 2 is equal to precedence 2 is also 1, so the precedence is same. Okay. And else, it means that the encountered character is a multiplication or a division, so I set precision 2 higher. Precision 2 is equal to 2. Okay. And then what I do is then I check this, that if precedence 2 is less than precedence 1, recall that precedence 2 is the precedence of the operator on the stack, and precedence 1 is the precedence of the operator found in the infix expression. Okay. So if precedence 2 is less than precedence 1, then we have to push the operator, the infix, the operator we encountered in the infix expression. So if it is less, then the stack dot push operation top, operator this. Okay. And all right, we will okay. And we break this. Okay. Else, what we do is we just attach to output. We pop this from the we attach this operator that we popped from the stack to our output. Okay, one thing that we forgot is here, after the switch case, the switch case ends. Um, what we do is, we have to check if the stack is not empty. Okay, if the stack is, for example, when the infix string ends, still there might be some operators on the stack, so we have to read the stack as well. So we check while not the stack dot is empty. What we do is we just pop the values and attach them to our output string. So output is equal to output plus the stack dot pop. Okay, so now our operator method is ready, the got operator method. Then we had another method, got parenthesis. So what we check in this method is that when we actually call this method whenever we encounter closing parenthesis. So whenever we encounter a closing parenthesis in our infix expression, what we actually do is we check that if the stack is not empty, while not the stack dot is empty, all we need to do is we pop the character from the stack, and we attach it to the output string unless it's an opening bracket. When it's an opening bracket, then we stop. So what we do is we pop the character. Let's suppose I call it character chx is equal to the stack dot pop, sorry, the stack dot pop. And if this character is the character that we popped, if this is equal to an opening bracket, then we just break this loop. Else what we do is we just we attach to output whatever is popped from the stack. Output is equal to output plus chx. This is our got parenthesis method, and this is our infix to postfix class. And so now this all we need to do is in a main function test this class. So let's write the main function. In the main function, I instantiate this class. Let's suppose I call it into post ITP is equal to new into post, and I pass it a string which is, let's suppose, 1 plus 2 plus 3 minus 9 divided by 8. Okay, and then what I do is I so in this main function I instantiated this into post class, and I instantiated it with this string. It's and I call the doTrans function on this ITP object, and it will transform this string into postfix. And when I run it, I get the postfix. Let's verify if it's correct. 1 will be output here, 1 plus will go to the stack, then 2 will come here, then again plus. So we will see if there is a operator with same or less precedence, with more precedence on the stack. So on the stack we have a plus, so that plus is popped and comes here, and this plus is pushed onto the stack. Then there is 3, this 3 comes here. Then there is minus, again that plus will come here, and the minus will go on, will be pushed on the stack. Then there is 5, it comes here. Then there is steric, it has higher precedence than the minus which is on the stack, so this steric will be pushed on the stack. Then there is 8, will come here. Then there is this division, so its precedence is same as the multiplication which is on the top of the stack, so that multiplication will be popped and come here, and this division will be pushed onto the stack. Then there is 9, it will come here, the string finished, so all the remaining will be popped, and this is the postfix expression. So now, as I explained earlier, you have to use the stack again to evaluate a postfix expression which will not have any of these complexities as precedence or the operator precedence. So you just need to have a stack, and you will push all the operands onto the stack, and whenever there is an operator, you will just pop 2 operands from the stack and perform the operation and push the result back onto the stack.